Hi, my name is Paige Hingst, and I am the Tribal Response Program Manager from the Santee Sioux Nation, located in northeast Nebraska, and I'm also the co-lead for the Tribal PFAS Working Group. And today I'm going to talk to you about the world of PFAS. So we're going to talk about the evolution and general information, along with EPA's actions to address PFAS and PFAS as an injustice to tribal nations. So let's start with the PFAS 101, evolution and general information. Ever wondered where PFAS was discovered? Well, in 1938, Teflon was accidentally discovered when scientists were trying to develop a Freon refrigerant. Then in 1940s, Teflon was used for the development of the atomic bomb. By the 1950s, Teflon was used in almost every consumer industrial products. In the 1960s, the Navy patented aqueous film forming foam, or AFFF, and by the 70s, the majority of the industry was using it. In the 2000s, PFAS has been globally distributed and the effects of PFAS came to light, thus commencing a voluntary phase out of the products. Currently, we know so much more about PFAS and the effect it has. Like I said in the previous slide, PTFE, or Teflon, was accidentally discovered in 1938 by 3M. And we remember that by the 1960s, Teflon was a household name. DuPont, though, finds evidence that it causes toxicity in liver of animals in 1961, and in 1962 finds evidence of toxicity in humans. In 1976, 3M finds PFOA in workers' blood, and 5 years later finds PFOA causes rare birth defects in rats, all the while still manufacturing PFAS. That same year, DuPont workers give birth to infants that have similar rare birth defects as animals, so they remove the women workers from the Teflon unit, but don't share any of this data with EPA. 3 years later, DuPont finds PFOA in a community's drinking water, but doesn't disclose results to anyone. And in 1987, 3M looks for uncontaminated blood samples to compare to their workers and finds widespread global contamination. So now that we know the evolution of PFAS, let's look at what PFAS is. It is a very large class of synthetic chemicals that are made up of carbon and fluorine atoms with different terminal ends. Some estimate that there are over 12,000 PFAS chemicals and are widely used in industrial and consumer products. They are very mobile in the environment, and some are known to be PBT, meaning persistent in the environment, bioaccumulative in organisms, and toxic at low levels. The most common PFAS is PFOA and PFOS, as we see on the left side of the slide. So why is PFAS such a concern? It is estimated that 99% of the world population has some level of PFAS in their bodies. Also, many of the world's animals also have PFAS present in their blood. Toxicity studies show adverse effects at low levels of exposure for some PFAS, including PFOA, PFOS, Gen X, PFHXS, and PFNA, and PFBS. PFAS exposure may cause decreased fetal and infant growth, weaken immunity systems, elevated cholesterol, and can cause some cancers. They've also been known to cause kidney and liver disease. Studies seem to show that humans are more sensitive to PFAS than animals. Where we are seeing health adverse effects at parts per trillion, animals are seeing them at parts per billion or parts per million. Let's look at types of PFAS. There are non-polymer PFAS where chains don't repeat themselves, and polymer where there is repeated chemical structure like PFTE or polytetrafluoroethylene. There is perfluorinated and polyfluorinated. An example of non-polymer PFAS is PFOS. Types of perfluorinated PFAS are PFAAs, PFCAs, PFSAs, PFOAs, and PFOS. Some polyfluorinated chemicals are FTSA, FTCA, and FTOHs. Precursors of polymers and polyfluorinated PFAS can degrade down to perfluorinated chemicals. The non-CF bonds are links that are weak in the chain and can be broken by biotic or abiotic reactions. This slide shows you how polyfluorinated chemicals can break down to form perfluorinated chemicals. Because of the adverse health effects of the longer chain PFAS, new shorter chain PFAS were developed to replace them. Gen-X is one of these replacement chemicals. These new shorter chain PFAS are less studied than the longer chains. EPA has set MCLs, or maximum containment levels, for 6 PFAS in the National Primary Drinking Water Regulation. On the next slide, I'll discuss how to find the hazard index if you have a mixture containing 2 or more of PFHXS, PFNA, Gen-X, and PFBS. The PFAS hazard index is used to understand health risks and was developed for the PFAS National Primary Drinking Water Regulation. To calculate the hazard index, you first divide all measured concentrations by their health-based value. Then add all the ratios together. To determine hazard index compliance, repeat the first 5 steps for each sample collected in the past year and calculate the average hazard index for all samples taken in the past year. If the running annual average hazard index is greater than 1.0, it's a violation of the hazard index MCL. This slide shows the targeted methods to test for PFAS. VCS, or Voluntary Consensus Standard, leaf or leaching environmental assessment framework, which consists of 4 testing methods. Here is some methods to test for total PFAS. You have organic fluorine, which is method 1621, or a total oxidizable precursors assay, which is still under development. So now I'm going to talk about EPA's actions to address PFAS. Here are the steps that so far EPA has taken to address PFAS. They proposed PFAS to be listed as a hazardous constituent under the Resource Conservation and Recovery Act. They've been testing for methods for measuring PFAS in the environment. They did adding PFAS as a national and enforcement compliance initiative. And they did the National Drinking Water Standard to limit 6 PFAS substances. Here's some more actions they've taken. They've made the PFAS analytical tool, which is a great tool. It can find out any type of PFAS that may be affecting your area in the drinking water. You can go use this tool. It's a great asset. They also proposed PFOA and PFOS as a hazardous substance designation under CERCLA. And they've done some clean water PFAS actions, such as addressing PFAS in NPDES permitting. In the last slide, they've done some final human health toxicity assessments for Gen-X chemicals. They've made the national PFAS testing strategy. They made the EPA Council on PFAS. So they've done quite a lot of things to address PFAS. So now I'd like to talk to you about PFAS as an injustice to tribal nations. Historically, tribal nations have been the victims of many injustices. Tribes lost their lands to white settlers and the government through broken treaties and promises. Many were forced to relocate and assimilate to the white man ways. Their main food source, the buffalo, were hunted almost to extinction. Tribes were placed on reservations that were unsuitable for living, let alone for farming. Most tribes were given undesirable lands. Because of their sovereign status, many tribes were exploited by big companies and the government. Specifically, the DoD has been known to deed old military bases to tribes without cleaning up the contamination, leaving the tribe to do it. Currently, 48% of tribal nations lack access to clean and safe drinking water. I'll speak more about this later in my presentation. A lot of tribes live in rural areas where lack of jobs and transportation prevent them from being able to go to the nearest supermarket, which could be an hour or more away from where they live. Those tribes rely heavily on subsistence foods to live, such as fish, deer, and other game animals. They also use many different types of food for cultural and traditional practices. There are 475 federally recognized tribes. I know my slide said 74, but there are 75 federally recognized tribes and more than 400 tribes that are not federally recognized. There's 63 tribes that are state recognized in 11 states, which include Alabama, Connecticut, Georgia, Louisiana, Maryland, Massachusetts, New York, North and South Carolina, Vermont, and Virginia. Currently, there are 140 confirmed PFAS sites within a 5-mile radius of tribal lands. There are also 2,815 sites that are suspected of PFAS contamination. These suspected sites include landfills, military bases, industry, and wastewater treatment plants. There are 326 reservations throughout the U.S. 58 of those reservations are within 6 miles of an active military installation. 18 out of 450 military installations have confirmed PFAS contamination. 6 out of the 18 installations have over 100,000 parts per trillion of PFAS in their groundwater, which exceeds the EPA interim lifetime health advisory of 0.004 parts per trillion for PFOA and 0.02 parts per trillion for PFOS. 19% of all tribes are within 6 miles of one PFAS source, while 10% are adjacent to at least 2 or more PFAS sources. 80% of tribes are within 10 miles of at least one PFAS sources, where 70% are within 10 miles of at least 2 or more sources. Water is sacred to tribal nations, and protecting the water is vital. Unfortunately, many do not have running water to their homes for drinking water or domestic use. Over 48% of tribal homes lack basic access to safe drinking water. Water delivery systems are undeveloped and underfunded in Indian country and are in disrepair due to lack of technically trained tribal members who can maintain water systems correctly. There are 6 million tribal members in the U.S. Of the 6 million, 1.3 million tribal members are served by 847 tribally owned public water systems. The remaining 4.7 million tribal members that are not served by a tribally owned public water system rely on unregulated water sources such as private wells, rainwater harvesting, spring water, delivered water, rivers and lakes, and livestock water points. These unregulated water sources pose a high risk of exposure to PFAS due to no testing or monitoring. Another shortfall on tribal lands is the lack of sufficient sanitation systems. Most reservations have unlined landfills, which have been known to be a source of PFAS contamination. Illegal dump sites are prevalent on tribal lands, and we can assume that these are also a route of exposure. According to Indian Health Services, tribal members have long experienced lower health status when compared with other Americans. For example, life expectancy for tribal members is 5.5 years less than all other U.S. races. They have high rates of lead poisoning, anemia, diabetes, kidney disease, liver disease, and certain cancers. PFAS substances in the blood can exacerbate these conditions. PFAS has been linked to an increased risk for diabetes and chronic kidney disease. Further, PFAS has also been linked to having a synergistic effect with lead, meaning that they are interacting together to produce an effect that is greater than the cumulative effect that these processes produce when used individually. PFAS has been known to change liver enzymes, which can lead to increased risk for liver disease. Tribes are more vulnerable to pollution than other disadvantaged groups because of their reliance on their environment for cultural practices, subsistence foods, economies, and overall livelihoods. Tribal reservations have long been targeted as locations to dump industrial waste, which have polluted rivers, lakes, and tribal lands across the country. Tribes were and are exploited by private companies hoping to take advantage of their chronic unemployment, pervasive poverty, and sovereign status of tribal nations. The pollution, vulnerability, and environmental degradation has impacted tribes through their medicinal, traditional, and ceremonial practices. Environmental degradation has led to the loss of traditional cultural practices that rely on local plants and animals that tribal communities hold sacred. Traditional practices, such as basket weaving, could be a route of exposure as basket weavers place the reed in their mouths while weaving baskets. During ceremonial practices, tribal members have been known to drink unregulated water from a historical source, increasing their risk for PFAS exposure. This is a conceptual map of direct and indirect exposure routes. These exposure routes are congruent with routes of exposure for PFAS. Routes of exposure include inhalation of PFAS through the air, direct soil exposure, exposure through sweat lodge and ceremonies, processing of animals, wildlife, gardening, irrigation, etc. As sovereign nations, tribes are responsible for their economies and revenue generating ventures for their communities. In an already struggling economy, PFAS contamination can have a detrimental effect on tribal communities that are already struggling. Tribal nations experiencing PFAS contamination could potentially lose important revenue needed to keep their communities going. One tribe in the Northwest U.S. had such an experience. The public water system that was serving their casino came back with very high levels of PFAS. They closed the casino down for a few days to locate an alternate water system. Loss of revenue from casinos can be in the millions of dollars and threaten tribal economies and communities. As you can see on the right side of the slide, PFAS remediation has cost states and the DoD millions of dollars. PFAS remediation for tribes would be very expensive and difficult, as most tribes do not have the resources to pay for costly remediation. In addition, testing for PFAS is very expensive, somewhere between $400 and $600 a sample. Therefore, testing on tribal lands is infrequent due to the cost. Disadvantaged communities is hard to define as each agency uses their own definition in order to determine who qualifies as a disadvantaged community. However, between all the different types of definitions, it can be easily defined as areas which most suffer from a combination of economic, health, and environmental burdens. In order to determine how PFAS affects disadvantaged communities, one must look at the key trends that link these communities together. The University of Michigan, in 2020, released a project that gave a ranking system to the 100 most disadvantaged communities. Analysis of their research showed that there were three key trends that disadvantaged communities shared. First one is that out of the 100 communities, 80 of them were in rural settings. They state that this finding is significant as rural areas are more likely to lack infrastructure and economic growth. 54% of tribal populations live in rural areas. The second trend is historical events. The most common theme they ran across is that these areas had a long history of racial and environmental exploitation. Health and economics round out the third trend. As we know, tribal members who live in disadvantaged areas tend to live 5.5 years less than the average population, and 1 in 3 tribal members live in poverty. The median income for tribal members is $23,000 per year, which is 30% lower than the national average. What was alarming about this project is that the top 2 most disadvantaged communities were counties that are homes of 2 distinct tribal nations. Tribal nations that live in rural areas are likely to have high levels of poverty, health disparities, and environmental pollution. Tribal communities that live in rural areas are less likely to receive funding from outside of federal agencies. In 2017, First Nations Development Institute noted that only 0.3% of all foundation funding is directed toward Native American causes in the U.S. Furthermore, as foundations and federal programs strive to measure their impact and efficiency by reaching large number of people, sparsely populated rural areas have seen a decline in funding over time. A prime example of this is I applied for a grant to develop a summer youth group that would focus on litter and recycling. I applied through a Nebraska Environmental Trust for $2,000. My proposal wasn't accepted because we didn't service enough people. So tribes must rely mostly on federal agency funding to deal with PFAS contamination. However, there is only so much available federal funding, and thus tribal communities who are dealing with PFAS contamination could possibly continue to deal with this contamination for an extended period, further exposing tribal members to cumulative pollutants. Food security and food sovereignty are extremely important for tribal nations. Potential PFAS contamination can jeopardize subsistence foods and or agricultural crops. Recently, there have been an increasing number of deer and fish consumption advisories for PFAS contamination. Most of the advisories are posted in states surrounding the Great Lakes region, such as Wisconsin, Minnesota, Michigan, Indiana, and New York. PFAS contamination threatens tribes that rely on fish and wild game for subsistence foods. Tribal members are less likely to be aware of these advisories or the risks associated with eating contaminated fish or wild game compared to the general population. PFAS research and testing for tribal nations is profoundly lacking. One of the major sources of PFAS exposure for tribes are from cultural and traditional practices. Tribes are very underrepresented in research and testing. For example, a paper conducted by the PFAS Project Lab group spoke about the underrepresentation of tribes. The group stated that there is approximately 6 million tribal members in the U.S., and approximately 1 million are served by public water systems with Native American owner type. Under UCMR 3, which is the Unregulated Contaminant Monitoring Rule of 2012, only 27.9% of the tribal population served by public water systems with Native American owner type had their water tested for PFAS. Because these numbers only account for tribally owned public water systems, there is a probability that a higher percentage of the general tribal population has had their water tested, but data is lacking on this to be for sure. In comparison, 79.1% of non-tribal populations served by public water systems had their water tested. Under UCMR 5, 2021, 64% of public water systems owned by Native Americans will be tested, compared to 92% of non-tribally owned public water systems. The questions that need to be asked is, how do we move forward? What needs to be done? There needs to be more funding for infrastructure so all tribes can have access to clean and safe drinking water, as is every human right. Adequate sanitation systems need to be built so that solid waste can be properly managed in a way that it prevents PFAS from leaching out. As I discussed in my previous slides, tribes lack funds to remediate contaminated sites. Most of the contamination that happens on reservations were not done by tribes, but they are responsible for cleaning up the contamination. This is where manufacturer responsibility needs to come into play. Any manufacturer of PFAS and its constituents should be responsible for the contamination. They made millions and billions of dollars off their products that now is posing extreme risks to tribes. More research and testing needs to be conducted so that tribes are aware of the extent of contamination. They can protect their people and their cultural and traditional practices and their subsistence foods. Outreach materials for tribes need to be developed so that tribal nations can inform their communities of the risks and exposure routes of PFAS. These are only a few things that can be done. There is more work to be done to ensure the health and protection of tribal members and the environment in which they live. And here are my references. And here's my contact information. If you need to get a hold of me, if you have any questions, my name is listed up on top as Paige Hingst, and I'm also a member of the Tribal Science Council. That's what TSC stands for. The other lady is Diane Barton. She is my co-lead for the Tribal PFAS Working Group, and she can also be reached at that information. She is also the chair of the National Tribal Toxics Council. We do have a website page at that you can access any type of PFAS resource you need, and we also have a Facebook page that we post on. And that concludes my presentation. Thank you.